The topic for this video is probability. The objective for this video is that I can find the probability of independent events. We're going to start about talking about the probability of single events and then putting two events together that are independent of each other. Let's start with talking about coins. If we were to take a coin, and we're just familiar with the idea of flipping a coin and checking out whether it's heads or tails. What's the probability of that? Well, the probability of flipping a coin and getting, let's say, a heads is one success out of two. So it's 1/2. But what if we were to flip two different coins? If we were to take these coins and flip them separately, they're independent events, the coins are independent. So if we were to talk about coin 1 and coin 2 here, the possibilities of what would happen is we could get a heads on both, we could get a heads on the one and tails on the other, first and second. We could get a tails on the first and a heads on the second, and we could get a tails on both. So the probability, if we were to look at this, of getting heads and heads for these two, that possibility is one success out of the 4 possibilities. That equals 1 out of 4. Let's talk about cards, for instance. If you take a deck of cards and you shuffle them well so that they're all randomly shuffled together, you can look at selecting out a card. And if you select out, for instance, the possibility of selecting out a 10 out of this deck, there are 4 10s in each deck of cards. So if you were to shuffle them, select out a card, your probability of getting a 10 out of that deck of cards is equal to 4 successes out of the 52 total cards in the deck, which would reduce down to 1 out of 13. Now, what if instead we wanted to pick a red card out of this deck? If you were to look for the probability of a red, there are 26 red cards in the deck out of 52. Half the deck are red cards, the other half's black, so that possibility would be 1 out of 2 of getting a red card. What would be the possibility then of the probability then maybe of getting a diamond? Okay, there are different cards in the deck, and there are 1/4 of the cards, or 13 out of the 52, are diamonds, so that would give you a probability of picking a diamond as 1/4. All right, now let's look at dice. Okay, you take a couple dice here, and let's say I roll a die. I look for the probability of getting in this case I got a 2. So probability on the dice of getting a 2 would be 1 success. There's only 1 2 on the different faces of the die. 1 success out of 6 different faces. Okay, what if I wanted the probability then of getting an even number when I would roll it? Well, the probability of getting an even number, when you look at it, there's 3 of these numbers on it are even, 3 of them are odd. So you get 3 out of the 6 would be success, which would be 1/2. Now, we also sometimes talk about having a problem like having a bag full of marbles with different colors in it. For instance, this bag has 4 green marbles, it has 3 red marbles, and it has 5 blue marbles. If we were to take a marble at random out of that bag, what would be the probability that it would be a green marble? Well, we'd look at the success would be 4 out of the total of 12 marbles in the bag, would reduce down to 1/3. What about the probability of getting a red marble out of that one? Well, that's 3 successes out of the 12. That would reduce down to 1 out of possible 4, 1/4, 0.25. And what's the probability of getting a blue marble out of that one? Well, that possibility would be 5 out of the 12, which doesn't reduce. So those would be our probabilities of the different events if we just did one of them. Now, what if we wanted to do something like this, where we said, what would be the probability of the event of getting a 2 on our dice? So I'll put dice here, we get a 2 on the dice, and a probability of getting the coin to be a heads. So coin is heads. What's the probability of both of those happening. If we were to roll the die and flip the coin, they're independent events of each other. Well, we have a rule that helps us with this. If the events are independent of each other, then the probability of both of them happening is going to be probability of A times the probability of B. So in this case, it's going to be the probability of the dice being a 2 and the coin being a heads would be 1/2 times, the dice would be 1/6 and the coin would be 1/2. My probability together would be 1/12. Check out this one. Notice we just did one originally with this. 2 separate coins independent of each other. We listed all the possibilities and it ended up being 1/2 times 1/2 to get a heads and a heads. Okay, if we were to pick, for instance, here, if we were to pick a marble out of the bag, so we'll put a marble first, and we want that marble to be a green marble. And we want out of the cards, let's say we want to pick out a diamond, okay? So green and a diamond, so those are independent events of each other. So getting a green marble was 1/3, and a diamond up here was 1/4. We multiply those two together, we also get 1/12 for that. Okay, and last one, let's do one more example. Probability of getting let's do a even number for the dice. And let's do, on this one, let's do a 10 on the cards. So even number would be 1/2. A 10 would be 1/13. And so our probability would be 1/26. That's that possibility. So if we want to find independent events and find the probability of those happening together, all you have to do is find the probability of each of them individually and multiply those two together, and you'll get the probability of them happening.